So the AC signal, it is macam ni kan? Sine wave, or sometimes ada jugalah kalau kita nak tukar square wave pun boleh. Okay, but then for the AC signal is the continuous signals which we have the positive and negative. This is positive, this is negative cycle. Okay, so for the AC signals, AC signal, AC power, AC voltage, since it is sine wave, so dia mesti ada amplitude. The amplitude is Vmax. Okay, Vm, Vmax. Or sometimes it is also sama dengan Vp, V at the peak. Okay, and here is Vmin, kan? So yang atas dua tu will be Vp, V peak to peak. Vpp is V peak to peak. Okay, from maximum peak to the minimum peak. And Vpp equals to Vp over 2. Kan dia kena ambil half lah. Okay, alright. So for the AC signal, since it is sine wave, so dia ada positive and negative cycle. Okay, and what are the other components yang kita ada kalau sine wave? Dia ada apa tu? Ataupun dia punya this one, sine apa-apa kan? So that one kita panggil as phase ataupun frequency. Okay, this is the components needed for the sine wave signal, which is AC signal. Okay, so for the AC signals, selain daripada the amplitude, okay, selain daripada amplitude, we also must have the informations for the frequency. Okay, so dia macam in AC signals banyak benda informations that we must have. The amplitude, maximum and minimum peak. Okay, why we must know maximum and minimum peak? Because kita nak tahu also it is at the positive peak or negative peak. Okay, Vmin or Vmax. Okay, for the frequency, because we want to know also dia dekat point mana. Nak point rendah sini ke? Nak point sini ke? Okay, because this one is determined from the frequency juga, betul tak? Dekat angle dia berapa? Okay, so for the AC signals, dia macam banyak benda informations must be carry. And also for the AC voltage, for the AC signals and AC current, it is actually not stable because ada banyak banyak informations yang ada, banyak components. Okay, and not stable, what else? Sekejap ya. Okay, and the rectifier is actually, it is part of the power supply. So part of before kita pergi ke supply yang kita nak pakai. Contohnya to your charger, nak charge the handphone. Okay, for the your everyone's punya daily punya usage, kita nak charge ni, kita nak pakai AC ke DC? Nak pakai yang ada CC. Saya tak kisah benda asalkan masuk power. Kalau nak jadi engineer, kenalah berfikiran kreatif sikit, critical sikit. Apa Muklis? AC ke DC? DC, direct current. Okay, and actually semua barang-barang kita dekat rumah, semua components ataupun barang-barang elektrik, it is DC. Kalau you tengok yang paling senang, kenapa saya selalu bagi contoh charger handphone? Because semua orang ada charger, ada handphone. Okay, and then itu adalah yang paling senang untuk kita tengok. At the charger port, kepala charger tu dia mesti ada tulis voltage dia berapa. Okay, and for the charger normally 5 watt, 5 voltage. Untuk laptop, for the charger laptop, you balik tengok charger masing-masing. Charger laptop yang adapter, that one around 20, I think not more than 20, 15 ke 20, lebih macam tu lah for the laptop. For the device like tablet, besar sikit daripada handphone, around 10 to 12. Okay, so that is the range for the supply untuk our usage of our devices lah. Okay, And it is comes from the signal, the supply yang kita ambil is comes from the 240. What will happen kalau kita guna yang 240 tu untuk charge? Sekali dah charger tu terkoyak sikit, kita pegang, what happen? Cacat terus rambut kalau masih bernyawa. Okay. So it is depends on our barang lah. Kalau barang kita nak 5 je, kenapa kita pakai 240? Okay, it will be lots of power waste, power dissipation. Nanti bil elektrik daripada puluh-puluh dah atau ribu pula kan. Okay, so it is bazir lah. And also in terms of bahaya lagi satu. Okay, not safety. And but then if you tengok dekat rice cooker, mesin basuh atau benda-benda yang needs lots of power, so the voltage dia a bit tinggi sikit lah. Tak samalah macam barang-barang yang kita guna. Okay. And from there, from the AC signal ni, we must get the, nak dapatkan apa untuk kita guna dekat usage kita? The DC signal. The straight line. DC signal is straight line. It only has the amplitude sahaja. Okay. So, rectifier is one of the parts dekat dalam block diagram dia. Rectifier is one part where it take place when the AC we need to convert into DC. Okay, so kita akan tengok in the rectifier apa yang ada. Okay, so dah faham sekarang why we need to study on the rectifier. Okay, faham? Saya dah habis dah. Terus dekat slide cover je. Okay. Inilah yang saya cerita-cerita tadi tu. Barulah tengok slide-nya. Okay, so ini history sikit lah. Bukan history, we recap back what is. Okay, so in the rectifier, kita akan pakai diode. That is why first 2A kita belajar diode dulu. You need to understand on the diode operations, what are inside the diode, how the diode can be built, majority carrier apa, minority carrier apa, functions dia macam mana, one way directions for current flow. Okay, barulah kita boleh tahu kat mana kita nak apply the diode. Actually hari-hari pun you pakai the diode, tapi dia dekat dalam benda ni, dalam charger and adapter, tak nampak. Okay, tapi sebenarnya sekarang macam ada juga power bank ke yang nampak all the circuits kat dalam kan. Ada juga kan. So kalau you tengok, sebenarnya ini actually for that tiny components, dia warna hitam, the IC integrated circuit, dia lebih kurang je. Tapi kalau you tengok deeper, mungkin lah, okay, this is diode, this is capacitor, this is transistor. Tapi all that things sebenarnya it is very small. Sebab tu yang kita belajar in 2A hari tu, the diode it is murah lah. Kita tak pakai components yang mahal. Okay, sebab it is very small. Dan sebenarnya if you tahu to construct with the electronics component, then easily can be replaced. Okay, alright. So now kita nak pergi deeper on where is the applications of the diode, especially in our daily usage lah. Okay, the diode is device with, it has two terminals but then only one way direction. Okay, applications of the diode is in the design of rectifier circuit. Okay, rectifier is the process to get the AC signal, but then we have a circuit. Dalam circuit we use diode as the components. Okay, rectifications is a process in which a rectifier diode converts an AC into a half or full. Okay, we have two types, half wave and full wave. Okay, later on sekejap lagi kita tengok on the half wave and full wave. Alright. Okay, so this is we have learned previously on the, once we have the diode, we have P type and the N type. Okay, from the intrinsic we can get the extrinsic. So the extrinsic will have P type and N type. I hope that you guys still remember. Okay, and then the diode we can use as switch. Okay, we can either guna as the forward bias or reverse bias. Okay, function as switch. Okay, if it is forward bias, meaning that it is closed circuit or on condition. The current can flow. Alright, so this is where the diode is in forward bias. So we have the diode kat sini lah sebenarnya. Alright, so the second one here, it is in reverse direction. So the diode will be like this. So the current equals to here. Apa Mukris? This is open circuit. Out of condition, there is no current flow, 0 ampere. Okay, the condition for the diode is reverse direction. Okay, the current cannot flow because diode is one way direction, kan? Okay, so this is when you want to use the diode as switch lah. Okay. Sometimes for this one, kita dah ada the circuit. Okay, we don't change the the connections of the diode. We just change the polarity of the supply. So for the supply ni kita boleh sambung dengan one switch, baru pergi dekat the circuit. So switch tu lah on dengan off. Tapi sebenarnya kita nak menentukan the directions of the diode, tapi kita tekan the switch. Macam tu switch di situ lah. Contohnya depan dengan yang belakang. Alright. Okay. So that is on the diode. Okay. So now we have two types of the rectifier in chapter 2b here. First is on the half wave. Okay. Half wave rectifier. The circuit nanti kita tengok. Okay. This is AC signal. Continuous AC signals. We have positive and negative cycle. Okay. For the half wave, it can only allows for either positive or negative. Satu je. Now this one yang ditunjuk contoh here is only for positive cycle. It will convert the signal for positive cycle only. For half wave. Sebab dia half. Either one lah. Kalau nak for positive, the connection macam gini. Adalah on the circuit. Okay. So if for negative cycle, dia kena tukar. Contohnya if we have switch, tekan switch, baru dia boleh buat for the negative cycle. Okay. Ataupun tukar the circuit, baru dapat for the negative cycle. So it is either one. For positive or negative cycle. Only or. Dia kena or. It cannot be and. For the half wave. So kita tengok on the circuit. This is on the circuit for half wave. So the first one, dia akan lalu only one cycle lah dia boleh ambil. It cannot take for both cycles. So only one cycle. Kalau ambil positive, so it will get on positive. If it is on negative, so dia akan jadi on negative. All negative lah because it is continuous. So the signal akan kalau positif semua. Tapi the signal akan terputus. Okay. Alright. So the circuit dia akan lalu from here goes this one. This is for positive cycle. Okay. V out is dekat sini. This is for V out. V out as at the resistor. Okay. This is for positive cycle. Okay. If for negative cycle, positive dia punya polarity is this one. Okay. So for negative cycle, kita kena tukar the polarity. And then the current akan lalu macam ni. Sorry. sorry. This one is for off condition. Sorry. This is for off condition. Okay, untuk yang ni, sorry. This one kan dia ada this Okay. For this still for positive cycle. Tapi kenapa yang the second ni, yang ni dia jadi tak ada? Because it is on, lepas tu dia off. So for off, the current cannot flow sebab why? Sampai sini? Sebab directions of this polarity of the diode terbalik juga. Kan? So that is why dekat sini dia akan jadi off. So dia jadi tak ada. Alright, so this one is for off. And to get the value of the VDC, this is the formula. 0.318 comes from 1 over pi. Okay, 1 over pi equals to 0.318. Okay. Okay, for this diode this is for off conditions, and conduct for this negative cycles. It is actually wants to conduct for negative cycle, tapi since the diode is off, so there is no signal. Okay. These types of circuit in which a single rectifier diode is applied with a time varying sinusoidal AC signal input to generate a DC output having a value half of the input. We call it as a half wave rectifier. So this one lah, dia dapat half sebenarnya, almost half lah daripada yang this one. Okay, so this will be the output for half wave rectifier. Okay, for this one example, we have one circuit here. So yang berbeza this one is this. So if we lalu kat sini tak boleh kan? Why? Because this is in reverse bias, so it will be off. For positive cycle, sebab tu dia yang ni off. Sorry, situ pula. At the positive cycle is off, so there is no signal. Okay, so what we can do is kita boleh tukar on this one. Okay, we change on the polarity, so the current can flow here. So we have on for negative cycle. Okay, so this is the VR output for negative cycle. So kita dapat here is negative. Okay, this one, if apa soalan dia lagi? Okay, if this is for silicon, we need to minus. Kalau the diode is on silicon, we need to minus 0.7. So the formula will be 0.318 Vm. Just now 0.318 Vm only. That is formula. Mana formula dia? Okay, that is kalau 0.318 Vm without minus is the ideal diode. But then remember hari tu when I explain on the IV characteristic for the ideal diode, dia macam ni kan? But then actually in real conditions, in real applications, there is no such ideal diode lah. Okay, so kita kena minus dengan VT or VD sama je. Okay, this one VT equals to VD. Okay, the value of the diode. So if we use the silicon, so kena tolak lah dengan silicon. Okay, minus 0.7. Okay, yang ini we replace for the C tu. Kalau tengok soalan here, replace the input. Okay, replace the input to 200, so you dapat extra lah. Mana dah? Okay, the 200. Okay, so this is if the input is 200. Alright, so okay, on the half wave, okay, the half wave rectification is a process in which one half of the cycle and eliminated by the diode at its output. So only will have one cycle only at the output, either positive cycle or negative cycle, depends on the circuit lah. Okay, so next one, we have the full wave. Okay, next one we have the full wave. For full wave rectifier, we have two types of circuit. The bridge network and center tap transformer. Okay, these two types akan ada different circuit lah. Okay, for the bridge network, it can convert high AC to very low DC. Okay, sometimes our components ni tak nak DC yang supply tinggi. Okay, might be only needs around 3 watts, around 5 watts. So we can use the bridge network. Okay, full wave rectifier circuit is the circuit that rectifies the entire cycle. Meaning that we can have for both cycle. That is the difference between the half wave and full wave. For full wave, both cycles akan ada at the output. Okay, and the circuits depends on the circuits. Once if the circuit this one use 2 diodes. Kalau use 2 diode, maksudnya in the formula later on must be minus 2 VD. Tolak 2 kali lah. Okay. Okay, one pair of diode might be on one cycle and another diode is on another cycle lah. Okay, so this one here, this is the AC signal input. Okay, so this one will be the output of the full wave rectifier. So we have positive cycle and negative cycle. So now we have all the signals. They akan convert after the rectifier full wave circuits. We can get all the positive cycles value for the full wave. So that's the difference between half wave and full wave. Okay, you might feel sekarang madam banyaknya teori-teori. Begitu bersemangat mengangguk. Okay, actually yes, you kena faham this theory because dekat dalam part A dia boleh tanya this kind of question. What will be the output for the full wave? So dia tunjuklah 4 gambar. Ya. Yeah? Apa dia? Ataupun tapi for the calculation can be also in the part A, tapi simple calculations lah, calculation yang bukan panjang-panjang sangat. Okay. So yes, you still need to know on the theory. Okay. Alright. So this is the first one is full wave bridge network. Okay, so for bridge network, we have in these connections or for this circuit, we have 4 diodes. Okay, 4 diodes we have, but then only 2 diode will be on for one loop. Dia akan lalu kat mana Zul? Dia dah fikir dah lalu kat mana. Dia lalu masuk sini and then D2 goes here, lalu D3 keluar kot sini. Okay, that is for one cycle. Okay, what we can do next is kita tukar dia punya polarity of this one. Dia akan jadi here. So dia akan masuk this way, goes D1, goes D4, lalu R, goes D1, keluar kot sini pula. Okay, so both of the way, dua-dua laluan akan lalu kod the R V out tu. Okay, that is why yang ni kita panggil as the bridge. Bridge ni lah. Sebab tu this one kita panggil as the bridge network. Okay. So bila dia lalu yang ni, satu akan on, this akan off lah. So we can get the positive cycle untuk first path. Okay, for the second path, we change on the polarity pula. We can get for the second cycle, for the second path. And then, the signals of the AC signals, dia akan continuous kan. Signal dia akan sambung je. So, kita tukar pula dia punya polarity. Tekan lagi, switch lagi sekali. Contohnya, you akan dapat the signal yang akan continuous signal lah. Okay. So we have the both positive cycles and negative cycles. Alright. So here is the formula to get the value. Dah dapat dah the signals ni. What are the value pula? Okay, what are the value of the VD here? VDC is 0.636 because now we have full wave and 2 diodes. So dia kena double from the half wave. Okay, kalau half wave 1/pi, full wave 2/pi. 2/pi berapa? .318. Betul 2/pi. Okay. Alright, so why here minus 2 VD? Yes, because we have 2 diode in a path. Satu laluan akan lalu 2 diodes. So the formula must minus 2 VD. Okay. The circuits, ini adalah the original circuits dia. Okay, for the full wave. But then for the alternative ataupun dia nak modify enhancement, dia boleh pakai 2 diodes. Okay, contohnya for this one, lalu here for first path, goes here, goes this way, keluar kot sini. Okay, for positive cycle. Okay, for negative cycle, we change the polarity of this one. Sini jadi positif, sini jadi negatif. So masuk here, lalu goes this way, goes here, keluar kot sini. Ataupun nak lalu this 2 ohm ni pun boleh lah, sama je. It can be either way because all these two is the same resistor. Okay, so this is for the negative cycle. Okay, and the circuits we can represent as this one. This is, let's say we have this point A and this is the point B. So this is point A, so this is point B. This one yang dah off tadi tu. Okay, so dia akan lalu this 2 ohms resistor, this one. Dia akan lalu kot this one, yang ni lah, this. Sekejap saya tulis. This is 1. This is 2, this is 3. So this is 1, this is 2, this is 3. Sebab dia in parallel. So for these circuits, dia dapat like this one lah. Okay, and this will be the output for this one here, output level dia. Okay, this is for another way. When we change the polarity for the negative cycle, still sama juga. So you get the second one here. Okay, the value akan sama lah, since the value we have here pun sama. Alright, so this is for bridge network. Okay, still bridge network because kita ada one output kat situ. Okay, so now, and then the output is dekat sini sebenarnya. Sebab at the resistor ni, tadi saya tulis resistor mana? Resistor 2. Oh, salah. Maksudnya sini, kalau sini 3, sini should be 2. So because here is at the output this one. So here is 3 lah. Sini 1. Sini 1, sini 2. Okay, so depends on the output at the resistor yang tengah tu. The output must be at the bridge resistor tengah. Okay, alright, so now we go to the second types of the full wave. We have the center tap transformer. You guys biasa belajar on the transformer kan? Kat mana? EPE, yes. Okay, so for the transformer, here we have 2 resistor juga. 2 diodes. This is primary winding, this is secondary kan? Okay, so this is for the first path, lalu here for positive cycle. Okay, for this one we change on the polarity. The current will flow for second path for negative cycle. Okay, for one diode connections is for one cycle. Satu for positive cycle, one for negative cycle. Okay, so for the first cycle, bila dia lalu here, yang ini akan off kan? Okay, so we get the first cycle, positive cycle. For the second one pula, we change on the polarity here. So we get the, lalu this one, so we get the negative cycle. That is for negative cycle. Okay, the process pun sama like as the bridge network, but then it is different circuit. Okay, the output is similar as the bridge network, but for the formula a little bit different, because in the transformer circuit we only have one diode. In the bridge, depends on the circuit lah, kalau ada 2 diode minus 2 VD. Okay, for this one here, the other things that we need to consider, if we use the transformer is on the winding ratio, kan? Okay, if now we have at the primary 2 at the secondary 1, meaning this transformer is step up ke step down? Step down, because ratio dia 1/2 kan? V2 lah, letak V2 equals to half of the V1. Okay, so dia step down, dia kurangkan the value. Alright, what else? Okay, so the ratio kalau yang tadi is 0.5. If the primary is 100, so at the output is 50. But then the output here is 50 if here is 100. But then it is 50, tapi kita ada 2. Satu dekat atas, satu dekat bawah. Meaning that one here is 25. Dia kena bahagilah. As long as the total is 50. Okay, kalau sini adalah 10, if I change 1, 2, 4. So kat sini adalah 40. So dia bahagilah 2. 20 and 20. Depends on the ratio tu lah. Okay. Lepas tu kalau you tengok here nanti dia tulis 25. How to get the 25? Depends on the ratio. Okay. And what is the value of 24.3 tu? VDC equals to VM minus the VD. Tolak lah. Okay. Minus 0.7. So you get the 24.3. Okay, that this is for center tap transformer. Okay, we have masa sikit. Okay, this is a comparison. Yes, comparison between the bridge and also the center tap. For half wave, these two is full wave. Okay. For the ideal diode, since if we use the ideal, kita cuma ambil the value itself only. Tak ada tolak dengan VD. Because this one we consider VD equals to 0. There is no voltage drop in the diode. Tapi bukan tak logik. It is not ideal. In practical there is no such condition like this lah. VD must have value. Baru boleh operate. Okay, kalau tak ada value, dia takkan boleh on actually. Okay, so in realistic VDC, this is the formula for half wave. VM minus VD. What is 0.318? 1 over pi, yes. Okay, what is the VM? Nah, what is VM? Apa? Syed Mukris dia jawab ni. Afika? Afika, what is VM? Yes, Vmax. VM is Vmax. Either dekat maximum peak or minimum peak. Okay, positive or negative lah. Alright, so VD. Why for the half wave minus VD? Afika. Anis. Why minus VD for the half wave? Yes, sebab guna one diode only in the circuit. Okay. And Pak Anis, Hani Dayana. Okay, Hani, for the bridge rectifier, why we call it as the bridge? tak nampak you lukis macam tu. Okay, dia pas dekat talian hayat sebelah. Siapa nama sebelah? Nadira. Okay, why Nadira? We call it as the bridge for the full wave. Tak ada. Ada girls lain yang nak bantu? Okay, mana Alisha? Okay, Alisha nombor 22.
Sebab
Yelah, kenapa dia nama bridge? Nak main game ni. Dah 9:30. Sayyidah? 2 diode minus 2 VD. Bridge. Why we call it as the bridge? Umairah? Seronok juga panggil girls ni. Okay, dah habis. Dah ada lagi girls yang saya tak panggil. Rabiata mana? Okay, Rabiata. Why? Sebab girls ni pemalu sangat ni. Mesti dia jeling saya dah. Tak adalah. Saya geraja. Okay, why? Because dah, tak nak dah. Malah lah fikir medal nanti otak saya keren. Saya perasan lah sekarang ni you guys. Bukan nak mengata you guys lah. Bukan nak mengata. Dia macam youth nowadays ni, dia macam takut nak berfikir di luar kotak. Nanti otak makin kecut ke? What will happen kalau kita think more? Pernah tengok iklan susu yang neuron bersambung? Kan ada iklan susu mesti macam tu. Actually and mom tu susu anak lah biasanya. Okay, actually my primary research, saya suka buat research on brainwave. Okay, so tak adalah kita study on the neurons, but then we study on brainwave signals. Kat dalam kepala kita, we have brainwave signals. So dia actually micro voltage lah, very low. Tapi it is electrical signal sebenarnya dekat dalam. Tetapi the more we think, the more our neurons will be connected. What will happen when all the neurons connected? Otak kita akan lebih aktif. Sebab tu kalau you perasan, I don't know lah you perasan ke tak, tapi sometimes kalau cuti semester lama, kita macam tak critical thinking sangat. So rasa macam kadang-kadang sometimes lambat pick up, lambat nak solve. Okay, if you always congak-congak soalan, do sudoku or some sort of exercise macam tu, senang je nak tangkap, nak catch up. Because our neurons dah memang active conditions. So dia senang nak catch up. Okay, what I want to convey here is the more you think, the more you will be, the brain will be active. Bukan badan yang aktif, the brain will be active. Okay, so and maksudnya kita akan lebih bijak. Lebih kurang lah. Okay, so don't afraid to think more. Okay, tapi janganlah fikir sampai anxiety, stress semua. Okay, kena life balance lah. Alright, so dah tak dapat lagi jawapan kenapa bridge. Okay, boys lah bantu. Okay, girls tak dapat. Why honey? Saya ingatkan tu cari jawapan kat dalam handphone. Because we have one resistor dekat middle one tu, yang tengah. Okay, so that one we call it as, sebab tu lah kita panggil as bridge. So every path yang kita buat for positive cycle or negative cycle, dia mesti lalu dekat resistor yang tengah tu, dekat bridge tu. Okay, alright. So that is for the bridge. For the center tap, only one diode, so minus VD. Okay, next class kita serang boys pula ya. Okay, so actually that is all for rectifier. Ini sikit je for peak inverse voltage, tak ada apa sangat. Okay, since the diode is can allow current for one direction only, so what will happen to the diode if the current flow, ataupun kalau kita ada current yang lalu very high value dekat the diodes. Okay, the diodes might damage. Okay, you biasa dengar yang fuse terbakar. Okay, lepas ni cakap diode yang rosak. Okay, actually that is due to the breakdown ataupun avalanche breakdown. Okay, so we will cover on this avalanche. So we will cover on this in chapter 2D Zener diode nanti. Okay. Alright, so kita nak main game sikit. Not ideal diode, but then the diode that can be operate for reverse bias. Okay, special conditions of the diodes. Okay, alright. So we want to play a game sikit. We go for this one dululah. Hopefully sempat.